Bob, sorry about that. And so the final talk is given by Daniel Hines. So he's at St. Joseph University working with Marcello Balducini on a language called Flamingo, Logic Programming Reborn for the Web. So he's going to give a talk on Flamingo, a compiler and runtime for reactive ALM systems.
All right, thank you. Can you guys hear me?
Yes, I can hear you and see you, and the slide.
Can you see the slides as I change them?
Yes.
Great, great. Okay. Well, thank you guys for having me. A little bit about me. I'm a web developer by trade. I make user interfaces that run in browsers. Most recently, actually, I'm doing something completely different and related somewhat to the previous talk. I'm working on the Tezos blockchain, and specifically to improve their smart contract language, Michelson. So I want to talk about the work we're doing at St. Joe's on Flamingo. So the problem that we're trying to solve is really that programming is very, very difficult, as you guys all know. In the limited experience and industry that I have, it seems like most of our effort is completely wasted. There's so much confusion on, and duplication of effort, and most of the time we spend is just trying to track down different bugs. My hypothesis, and I think this is shared with you guys, is that if we can write declarative logical specifications, this can help us to avoid waste. My further hypothesis is that if we can translate those specifications into efficient programs, that will reduce even more waste because you won't have to duplicate the efforts. So some existing solutions in this line of work are TLA Plus by Leslie Lamport and Alloy. These are both systems that I'm drawing inspiration from. They're wonderful for very hard distributed algorithms, like that have to time different concurrent events and that sort of thing. But for garden variety business logic, like, defining a mortgage or the plenty of other business problems, like it's just too hard. They presuppose deep knowledge of set theory, and the math terms as they show up, they just scare away most web developers who may not have ever taken any computer science courses. So the question is, can we make an easier, albeit weaker language from which we could synthesize efficient programs? So we're working with the language ALM, which was written by Michael Gelfond, he's online, and one of his students, Daniela and Klesen. So it's an action language in the tradition of McCarthy's situation calculus. I tend to think of it as like an extension of Datalog, but with action and change. It uses the answer set programming. Well, it's compiled down into an answer set program usually. And what I love about it is its minimal syntax. I wrote a parser for it and maybe 300 lines of code. It's been very, very easy for other people to pick up at least the syntax part. It adds to a traditional action language of this inheritance-based module system, somewhat akin to Java, which is very, very effective for building large and composable systems. So the modeling process for writing an ALM system is decide the objects in your system, decide the relationships between them, write your axioms, and then Flamingo will take all this in and compile it into a program that can run in your browser. So just to give you guys an idea of the inheritance system, suppose we import some module poisoned object from some sort poisoned object from the fairy tale module. We could define maybe like a fruit is a subsort of the top sort universe. This is equivalent to like the object type in Java, which is the top type in a directed acyclic graph. We could have an apple be a subsort of the sort fruit. So everything that is true of the universe is true of fruit. and everything that is true of fruit is true of apples. And then we could have some poisoned apple be a subsort of both fruit and poisoned object, showing that you can inherit from multiple parent sorts. So Dr. Gelfond's vision, as I understand it, is we want to create a high quality, like a large base of high quality tested modules for representing these common sense notions like physics, like when you travel from one place to another, or law, different legal relationships, or business processes, or even human relationships. You can encode all these things, all these common sense notions very succinctly in ALM. From there, we could mix and match different modules to quickly create high quality, robust, intelligent agents. So the Flamingo architecture focuses exclusively on the reactive case. So your agent isn't going to be planning a sequence of actions to achieve a goal. Rather, it will be responding to user inputs. So what the compiler does is it takes in your ALM modules and compiles them into an ASP program, which runs via the Klingo solver in the browser. This runs on a loop, so it observes an input action like a button click or a key press. It determines a response based on the axioms that you've programmed. It performs the response, updating the screen, and then it waits for the next action and does this in a loop. Another feature of Flamingo is that it supports queries, which are very short, horn clause expressions that describe some piece of the total state that you're interested in. So it forms a subscription to this, and it updates some part of your user interface reactively. This has been really, really nice for making complex user interfaces, and it ties in very nicely with modern web development practices. So future directions that I want to take Flamingo. I'd like to find a fragment of the language for which this property of that I'm calling safety is decidable. Safety, I don't want some predicate P and its negation to ever be true in the same state. That would be unsafe. So we're trying to find restrictions on the language, mainly around restrictions in arithmetic that will give us decidable safety. If and when we can complete that, I'd like to work on compiling Flamingo programs into efficient imperative programs. Right now, it compiles down to logic programs, but there's some research in Datalog on creating, bounded time and space programs from Datalog programs. And in the reactive case, ALM is very similar to Datalog. Now that I'm working on this Tezos blockchain, I'm very interested in smart contracts. And I think it'd be very possible to write these smart contracts in something like ALM. Especially if we can, I don't think that they would run on chain, but rather communicate with the chain itself via some oracle. And lastly, I'm interested in learning ALM rules from natural language descriptions. It sounds like Mr. Kowalski has beat me to this by a long shot, but I'm very interested in similar directions for ALM. So that's all I have. I don't think I have enough time to go into the concrete syntax, but you guys can find the documentation for Flamingo at flamingo-lang.org. I have a website up there that walks through a few examples. So do you guys have any questions?
Hey, thanks very much.